Okay, so now we're going through the first out of the six. Remember, it's just six stuff. Okay, so one, derivatives of exponential functions, and the only one we're going to do is e to the x. Okay, you're related to e to the x, right? Okay, we won't have like a number, some number a. Okay, like 7 to the x. No, we won't be doing that. We're only doing the ones with base e. So let's go for it. The first thing which you have to know is just the derivative of e to the x. Okay, the derivative of e to the x is just e to the x. This one you should know it. That derivative of e to the x. It's like if I write it this way to say y is equal to e to the x. That means dy dx is equal to e to the x. Okay, the derivative of e to the x is e to the x. That's the first thing you should know. So we want to know only two. Let's do the second one. Now, the second one, so the first part A is derivative of e to the x, right? Part A is derivative of e to the x. Then part B is going to be the derivative of anything else, e to the something else which is not x. It could be 5x, it could be negative x, whatever it is. How do you now do it when it's not an x, when it's something else which is not x? Let's do an example. So say, let y be equal to e to the f of x, something which is not x. Okay, we want to see as the second rule which you're going to use. Now, what would we say? We would say, so what would you have? This is a function, y is equal to e to the f of x. So to differentiate this, we would have to use the chain rule, okay? Because here, the first function is e, then the second function is f of x. F of x is some function. We said it could be like 5x, which is a function that multiplies by 5 or something, right? So what you would do is you'd say, let u be equal to f of x, which means y is equal to e to the u, okay? This f of x, this whatever will be your u, right? And then how would we differentiate it? We would say now, du dx is equal to f dash x. Okay, the derivative. Remember your notation that if you have f of x, the derivative will be f dash x, right? So if I differentiate u, I'm going to get just f dash x, right? Okay, which is the same thing. And then what about y? If I get dy du, remember y is in terms of u. So I can get derivative of y with respect to u because y is in terms of u. This is going to be equal to derivative of e to the x is e to the x, which means derivative of e to the u is e to the u, okay? If you're differentiating with respect to u. dy du is just e to the u, so I know that. Now I'm going to say dy dx, which is what I want, is equal to dy du times du dx. So it is going to be, what is dy du? E to the u times, what's du dx? F dash x. So it is just f dash x then times e to the u, which is going to be, what is u? U is f of x. So now I can put at the last stage, it will be f dash x multiplying e to the f of x. So this is what you must know, the second rule, that the derivative d dx of e to the f of x, okay, e to some function, it is going to be f dash x multiplying e to the f of x. So we can just write it to say f dash x then times e to the f of x. This is going to be my second law. So with this, I can now go ahead and do any question. So what is f dash x? You differentiate. So what this law is just saying, if you have anything else which is not x, differentiate it and you get f dash x, then multiply by the original function e to the f of x, okay? Multiply by e to the f of x, don't change. So differentiate it, then multiply by this original function e to the f of x. So let's do some examples. D dx of e to the x, this is just e to the x. All right, now let's get the derivative, d dx of e to the negative x. What is the derivative of e to the negative x? You differentiate. What's the derivative of minus x? It is minus 1. Multiplying, it comes back as it is e to the minus x. So this would be minus 1 e to the minus x. That's the derivative of negative x. Then let's see, d dx of e to the 3x. What is this going to be? Derivative of e to the 3x, you differentiate 3x, the top. Okay, you differentiate this, right? What is the derivative of 3x? It's 3, okay? Then you multiply by the original function, so by e to the 3x. Okay, if you want to write it in 2 steps, it's up to you. You can say d dx of 3x times e to the 3x. You differentiate the top, which is the derivative of 3x is just 3, e to the 3x. Then what about the derivative d dx of e to the negative 5x? Okay, e to the negative 5x. This is your f of x, isn't it? What do? You differentiate it. This would be minus 5 e to the minus 5x. Okay, that's how you do it. That's how you do it. Okay, if you have it as the derivative, if you wanted to do it in 2 steps, you could say d dx of minus 5x, then multiplying e to the minus 5x. It comes back as it is. The derivative of minus 5x is minus 5, then e to the minus 5x. Okay, you can do it in 1 step. It's nicer. So if I want to get that derivative, here's the last one. Just say e to the 3x squared plus 7. Okay, what is this going to be? It will be the derivative. So if you want d dx of 3x squared plus 7, okay, differentiate the top, then multiply by the function e to the 3x squared plus 7. Nothing changes. So here, 2 times 3 is 6. Derivative of 7 is 0. So it will be 6e to the 3x. Oh, sorry. It's 6x, right? Derivative of 3x squared, it's 3 times 2, 6. Then you reduce the power by 1 towards x squared, it becomes x. Then multiply the original function e to the 3x squared plus 7, which is 6x times, you can just leave it as times e to the 3x squared plus 7. And this is your final solution. This times is a dot right at the center. Okay, just means times. Now you are done. And that's it for exponential. We'll see more about it as we go along.